Hello, everyone, and welcome to session AIM 409. My name is Paul Zhao. I'm the Principal Product Manager for Amazon Transcribe. It's a pleasure to have you all here today. Joining me today is my friend, Dr. Javier Asensio-Cubero from Octopus Energy. And together, we're very excited to talk to you about custom language models, or really the ability to use a new feature to enhance transcription accuracy for speech recognition. A little bit about our agenda for today. We'll be talking about customer benefits after the overview of Amazon Transcribe, as well as the main use cases. We'll then dive into the details of how to use custom language models to improve ASR accuracy. And after that, we'll do an in-depth case study with Dr. Javier Asensio-Cubero from Octopus Energy. And then finally, we'll wrap up with a demo and talk about next steps. So, audio content is being generated at a dramatic rate today. It's growing regularly and exponentially at huge amounts. And there's just a ton of valuable insights that are trapped inside audio data. And we need a way to quickly, efficiently extract that valuable insight out of the audio data. And we need to do it at scale. To extricate value, we have to convert that audio from speech to text. And that means we need to run transcription. And yet, traditional transcription is often labor intensive, there's slow turnaround times, and it can be astronomically expensive when conducted at scale. Other ASR services do exist, but many of them are hard to use and require data science knowledge or some form of a priori machine learning. And still others offer limited accuracy and transcription needs, or occasionally are lacking key features that allow for user customization and configurations. By comparison, Amazon Transcribe is an easy-to-use automatic speech recognition service. It's fully managed so that you can focus on easily integrating the speech-to-text capabilities into your applications. And that means we do all the heavy lifting of the training, the maintenance, and improving of these highly performant speech recognition models. We expose the service as a set of really easy-to-use APIs so that you don't have to do any of the heavy lift in the back end. All you have to do is submit your audio to the service and get text in return. There's absolutely no need for management of DevOps, like I said, and there's no requirements for any form of a priori machine learning or speech recognition domain knowledge. So Transcribe, in a nutshell, is fast, it's accurate, and we provide the service today in either our asynchronous API or synchronous API. So that means you can submit an existing audio file for transcription, or you can submit an audio stream in real time for transcription. So, whether your use case is in contact center analytics, media entertainment, or even medical transcription, you can rely on Amazon Transcribe to help you convert speech to text for a variety of business needs. And we can do it at scale in a reliable way and in a very cost-effective way. Transcribe supports a variety of robust features. We're not going to dive into every single one that we have here today, but as a brief overview, Transcribe already supports transcription in over 30 languages and accents. All of our transcripts feature useful capabilities such as timestamping, which means traceability is very easy. We also offer very cool features like channel identification, which allows you to simultaneously identify audio channels within a single audio file, to simultaneously transcribe those channels and then convert it to text and get a coherent transcript at the very end of the day. We also feature things like speaker diarization, which allows you to separate one speaker from another speaker. And it's very useful for cases of doing subtitling, say for media use cases, where you want to identify one speaker talking about certain content and another speaker for different content. At any rate, we have quite a bit of these, and all of this is available to you for access at the end of the slides. We'll share resources to allow you to dive deep into each one of these awesome features. One of the things that we always like to talk about is transcription use cases. Transcription use cases are really not all the same. Maybe depending on your domain of operation, for example, in finance and law, maybe real estate, or even insurance, you have very sophisticated technical jargon, and generic speech recognition services simply aren't producing that level of accuracy that you need. Or maybe you have very specific speech syntax depending on the domain of operation that you have. So how do we exactly help you transcribe audio content better in these areas of operation, or specifically in these different types of domains? To do so, we're really excited to introduce a feature called custom language models. Custom language models, as the name suggests, allows you to leverage domain-specific data that you have to train custom speech models that are tailored for your specific transcription use case. At the moment, custom language models supports batch transcription. So let's take a quick look at how it is and how it works and how easy it is to actually get started to build your own custom models to transcribe domain-specific speech. First, what we'll talk about is preparing the training data, and then we'll move into how we actually train the CLM models themselves using that data. And then finally, we'll transcribe some sample audios and look at the newly generated CLM and the results. And then at the very end, we'll evaluate the transcription results by comparing the CLM output to the generic speech recognition service output. So in this walkthrough of how custom language model works, we'll use an example of a domain like video games, which often features a ton of technical jargon. And here we show you two transcripts of a sample audio discussing the comparison of two video game consoles. And on the left is the human annotated transcript, also called a ground truth or reference transcript. On the right is the machine transcript produced by a generic speech recognition service with no customization whatsoever. You can see that the generic engine did a decent job, but missed quite a few technical terms, such as brand names, video game console names, and also vocabulary pertaining to certain types of hardware and performance specifications. In the next few steps, we'll show you how to build your own CLM so that you can produce machine transcripts that are more accurate than what is output by a generic ASR engine. So first, we'll talk through what it means to prepare data. Number one, custom language models is built on text data, custom text data that you might already have. And most businesses actually already have this existing data that can already be used. So this can include examples like manuals, training manuals, instruction manuals, website content, brochures, textbooks, marketing materials, you name it. As long as it's in text form and represents your domain of operation or your speech recognition use case, you can use that. What matters is that you have this text data that's very representative of the language and vocabulary that's spoken in your business operation. There's actually no requirement to use acoustic data to build custom language models whatsoever. It's important to distinguish a little bit between two types of data. So one is called training data. Training data is domain specific. What that means is that in the previous examples that we listed, like textbooks, website material, marketing, collateral, all of these types of text data can be used for training purposes. We also distinguish that between that and use case specific data, which is often called tuning data. In the examples we previously mentioned, that tuning data would include text from human annotated audio transcripts of actual phone calls or media content. Training data is often used and required in the basic generation of the custom language model, whereas tuning data is entirely optional, but we do highly recommend it. In practice, you may have different constitutions of data between the training set and the tuning set. So in most scenarios, you might have large amounts of training data, but limited or no amounts of tuning data. In this case, you want to use the training data to, train, and then use the tuning data to tune. And we will show you how to do this very shortly. In the other alternative scenario, you might have just large amounts of training data and also copious amounts of tuning data as well. In this particular scenario, we usually recommend that you combine both data sets together and use it as one giant overarching training set. Whatever your splits between training and tuning data sets, both types of text data need to conform to certain guidelines. The details of which are available at the end of this presentation and in the slides for your reference and technical documentation. But generally following these guidelines, we've already kind of prepared in advance an example training set for you that you can see here on the screen. We've gathered the data using publicly available sources such as video game review sites, console hardware spec sheets, and video game synopses. Once we have this data ready, we upload that text file into an Amazon S3 bucket. We take that note of the we take note of the S3 bucket name, which we'll use to reference our training bucket location. And for the purpose of this walkthrough, we assume that uploading content to S3 is generally familiar to you already. Now that our training data is formatted and ready to use, let's begin the training of the actual custom language model itself. For demonstration purposes, we'll use the Amazon Transcribe Service Console. You can mirror all of these steps by also using the AWS CLI as well. So after logging into Transcribe Service Console with my AWS credentials, I'm going to simply select custom language models on the left-hand navigation pane. Next, we'll click on Train Model. And then the first thing we're going to do is name our custom model for easy reference later on when we're running the actual transcription. Following that, for my base model, I'm going to select wideband because I know the audio that I want to transcribe is a rich media type of file, in which case, it's often recorded at above 16 kilohertz sample rate or higher. So depending on your use case, you may opt for the narrowband, which is often used for training telephony speech models. In our case, again, we're going to stick with the wideband. In the next step, I'll input the S3 bucket location where I previously stored my training data, as I mentioned earlier. And for access permissions, I'm just going to select training and tuning S3 bucket and leave everything else as default. Finally, I just click Train Model, and pretty much that's it. Amazon Transcribe will do all of the heavy lifting. It'll automatically train the model for you in the back end, and there's absolutely nothing else that's really required. It's truly that simple. Now, depending on the size of your training data, the amount of time that it takes to train your model will probably vary. Here, we're fast forwarding a little bit in time to really demonstrate the point. But what I'm going to do here is show you on screen how to navigate back to my custom language model pane in the Service Console. And then I can see that my custom model has already completed training and is already ready for use. First, I'll start and name a new transcription job, as I would using General Transcribe. And next, I'll want to select my newly trained custom language model instead of using the generic transcription speech model. If I have tuning data prepared, I can select that tuning set, which also would have been uploaded to its associated S3 bucket location. And then I'll designate the S3 location of the actual audio sample itself. That's where the actual sample is stored for the file that I want to transcribe. Finally, I can choose my transcription output location, which can be a self-service, service managed S3 bucket, or it can be a self-managed S3 bucket of your choice. Then all I have to do is click Next to start transcribing my audio. Now let's take a look at how well our custom language model's transcription did. To do that, we can compare the text output results from both the general speech model as well as the original human annotated transcript. Here we're showing the side-by-side comparisons of a snippet from each to visualize improvements that CLM can offer. You can get a quick qualitative assessment of the differences, and you can see qualitatively that using CLM with training and tuning data gets you the best results, followed by CLM that uses training data exclusively. But we'll also want to do a quantitative analysis. Here we run a word error rate analysis, or WER, for each speech model's transcription performance on the original audio sample. All else equal, the lower WER, the more accurate the transcription is. And you can see from the chart that the CLM using both training and tuning data actually scored the best. CLM using training data came in second. And it's important to know that WERs are relative to demonstrate the point of using CLM over generic ASR models. These figures are only specific to this and not globally representative of all of Amazon Transcribe as a service. In this example, we also use very limited training data and tuning data, really just to demonstrate the point of how to use the feature. In fact, we use less than 5 megabytes of training data, and already you can start to see the transcription accuracies themselves. The key takeaway here is to really show you how powerful CLM can be in terms of driving transcription accuracy, even if we just do the absolute bare minimum and upload just a tiny amount of domain-specific data to train the model itself. Keep in mind that transcription performance of your CLM models will depend heavily on the quality and the quantity of your training sets and tuning sets. In general, it's always better to have more training data than less, but quality of data is more important, meaning you want your training text to be a good representation of the speech patterns and vocabulary in your use case versus just stuffing irrelevant quantities of training text into building CLMs. We encourage experimentation, and so go ahead and build some models and run a few test transcriptions to really see those iterations and how they perform. Finally, remember to properly evaluate transcription performance by measuring WER properly. To help you with that, we can refer you to a technical blog post about ASR evaluation techniques, which is also attached at the end of this presentation. Custom language models is a powerful way to leverage text data that you already have. As you saw, it's very easy to use. It requires absolutely no prior machine learning experience and hardly any data wrangling expertise whatsoever. So with CLM, you can build these custom models that are tailored for your use case to optimize for transcription accuracy for whatever domain of operation that you may have for your business. Custom language models is available in all AWS regions where Amazon Transcribe service operates. And as mentioned, CLM currently supports batch transcription. And now I'd like to invite my friend, Dr. Javier Asensio Cubero, who leads Octopus Energy's data platform, to really showcase how Octopus Energy uses Amazon Transcribe's CLM to serve their business needs and specific transcription accuracy needs.
Well, thanks, Paul, for the introduction. As you say, I work for Octopus Energy. We are an energy supplier and tech company based in the UK. And as a company, we have two main goals. The first one is to provide green energy at really fair prices. And the second and most important one for us is give an outrageously good customer service. And I'm going to brag a little bit about this last bit. So we've been the recommended energy provider here in the UK 3 years in a row by WIT, which is one of is the most important customer advisory board here in the UK. We have a 4.8 out of 5 score in Transpilot. Again, the most important customer review site in the UK, but not only that. If you look to the top 10 energy suppliers in the UK in Transpilot, we run 4 of them. And well, we also have like a wide range of different awards given by different bodies related to customer care and the energy industry. We almost have 2 million customers here in the UK. That means that we have a little bit more than 5% of the customer share here. And one of the reasons why we're so good at taking care of our customers is because we are really good at creating technology to support that. Our flagship product as a tech company is called Kraken. It's a mixture between a CRM, billing software, and communication software focused on the energy industry. And we license Kraken not only to the other energy providers in abroad, outside of UK, but we also license it to a few of our competitors. We operate in 5 different countries, UK, of course, Germany, the United States, Australia, and New Zealand. We had £1.8 million of annual revenue last year, and Kraken is making really happy to 6 million companies through our licensing. As you can imagine, as an energy provider, we spend tons of time talking to our customers. We process like around 1 million minutes per month of calls. And as a data-driven company, we are really interested in the contents of those calls. So we can do things like sentiment analysis and know how our customers are feeling. We can do automatic topic classification on those calls and more text analysis. When we decided to start using a ASR system, we decided to go for Amazon Transcribe, not only because of the quality of the transcriptions, but also because this possibility of being able to train a custom model to our domain. And I will talk about our model a little bit later, but first I want to talk about how we use Transcribe on a daily basis. So all the data-related tasks at Octopus Energy are orchestrated by Airflow. We have Airflow running inside Kubernetes, and every 15 minutes we will pull a batch of calls from the Kraken database, from our CRM, and then send them to Transcribe. Once the transcriptions are in a bucket, Kraken is able to pull them and show them to the energy specialists, who are the people that actually take care of our customers. But of course, the pipeline doesn't stop there. We have another bunch of tasks. For instance, we perform a topic classification over the calls. We offer the call content to our data analysts so they can pull the data and get more insights. And we also offer this content to the rest of the business via Elasticsearch and Kibana. When we started to train our custom model, we were really lucky because we have gigabytes and gigabytes of emails from and to our customers. And as you can imagine, the kind of conversation that happens in the emails happens in the calls. We have the same kind of terms and same kind of sentences. We also use a little bit of our internal documents and few reviews from our customers, pulling them from Transpilot. And why we wanted to have a custom model for transcribing our calls. We operate in a specific domain, which is the energy industry. So we have to tackle terms from there. And also we have terms that are relative to our business, to our own company. So as a first example, I want to talk about smart meters, which are a really hot topic here in the energy industry in the UK. So this creates a little bit of friction between customers and energy providers. So we have tons of calls referring to them. And as you can see in the first example, a smart meter gets transcribed into something like a smart meter start today. So that's using the default model. When we use our custom model, a smart meter gets transcribed perfectly, 3 times in this example. Another point that doesn't work that well, or didn't work that well, is about tariff and our tariff names. So our tariff names are completely specific to our brand. Not only the tariff names were wrongly transcribed, but also the word tariff the default model would struggle with. So as you can see in this example, we get transcription like flexible taras and flexible tawa. When using the custom model trained with our data, not only the word tariff gets correctly transcribed, but also the name of the tariff, in this case 12-month fixed tariff, gets correctly transcribed as well. And the last example that I want to talk about is not really useful in order to, do sentiment analysis or do text analysis over the calls, but it's quite important for us because it's the name of our company. The 2 words, Octopus and Energy, they don't appear that often in the wild when you train a model with a generic corpus. So in this case, training the custom model with our own data, we succeed into transcribing our greeting. Good afternoon, I'm the Octopus Energy. How can I help? So once we trained the model, we had to evaluate it, of course. Back then, we didn't have any human-made transcriptions, so we had to do a qualitative evaluation of the model. So what we did was transcribing few calls using 3 different approaches, one the custom model, another one the default model, and then the default model with a vocabulary. And then get some of our colleagues to vote over the results. And as you can see, the custom model performed way better. If you want to know a little bit more, like have a quantitative metric, you can use the word error rate that we computed afterwards. And as we can see, the improvement in the accuracy ranges between 12 and 21%, depending on the audio file. So now I want to present how we actually use the custom model on our daily lives here in Octopus Energy. The first example I'm going to show is a demo from Kraken, our CRM. So when one of our energy specialists are talking on the phone with a customer, they sometimes need to go to another call to review the content so they can improve the care, so they can take better care of the problem using the previous information. So what we're going to see is exactly that, what we call the Kraken karaoke. And in the video, you will see that not only you can browse through the contents of the call, but you can also hear the audio.
Hello, Octopus Energy, Lily speaking. How can I help?
Hi there. I got a smart meter, or 2 smart meters fitted by you guys 2 weeks ago, and I haven't had a bill yet, so I just wanted to check what was going on.
Sure. Can I take your postcode and the first line of your address, please?
Yes, it's N16 8SW.
Brilliant. And your full name?
David Sykes.
Brilliant. Thank you so much. All right, let me just give me a minute to look up what's going on your account. Cool. So yeah, it looks like we did install a smart meter on the 14th of October, and it looks like you haven't had a bill since July. Let me see if I can fix that. Give me 1 second.
As you can see, this is not only quite interesting in terms of the quality that you get from the transcription, but it also helps us to improve our customer service. The second use case that I want to talk about is about text analytics. So back in March 2020, when the UK went into a really strict lockdown, the British government wanted to know how the customers from all the energy providers were feeling about the pandemic, how worried they were about losing their jobs or being into furlough, and if they were communicating that with us. So we used our transcriptions to do some text mining, and we gathered the results for the report. As far as I know, we are the only one, or we were the only energy supplier in the UK, or one of the few that we were able to report this data based on our call transcriptions. Both the use cases that I was talking about, the Kraken karaoke and this one, of course, doing this work without having something as Amazon Transcribe would be impossible. So I think we think that this product is really, really good. Where to go from here? So one of the things that we want to do is move away from processing batches of calls into having a real-time processing. Not only because the transcription then gets to our energy specialists sooner, but also because then we can advise, we can suggest actions real-time to our energy specialists based on the content of the call. We want to do more sentiment and customer satisfaction analysis, and something quite important for us, that is compliance monitoring for our sales team. And well, before wrapping up and handing it over to Paul again, I just wanted to stress how for a business like ours, a data-driven business, being able to use our own data, our own domain-specific data to train a model to process the calls is highly valuable, because it allows us to better understand and serve our customers and their energy needs. Okay, thanks, Paul. Now back to you.
Thank you, Javier, for that wonderful demonstration. I really appreciate that. It's always a real treat to see customers like Octopus Energy be able to use a key feature like custom language models to demonstrate how it's making an impact for their business. On next steps, we recommend that you get started with a POC or test out the accuracy benefits that your business can see. Start with reaching out to AWS experts like solutions architects and partners who can help you with a POC. Thank you very much for joining us in this session, and appreciate your time. Please help us complete the session survey at the end.